Okay, so in the first lesson and the second lesson, first lesson we are dealing with the table of derivatives. Okay, we're dealing with the table of derivatives. I told you you need to try and get that in your mind. That is the foundation for calculus. That is the table of derivatives. You're going to see how we will be using it here. Even though you'll be learning new rules, like the product rule deals with multiplication of two variables. Quotient rule will deal with division of two variables also. And the chain rule also will be used everywhere, almost everywhere. So now, previously, from the table of derivatives, this is your standard table. Let's take an example. We have y is equal to, let's say, k sine f of x. So if we go to our table of derivatives, we got k sine f of x. And if I want to differentiate this here, the derivative will be k cos f of x. So the derivative of sine of your function of x is going to be cos of the function of x multiplied by the derivative of f of x, which becomes f prime x. Right. And this only applies if this here. So k is a number. Right, k has to be a number in order to do this. Now, what happens in a case? Okay, let's take an example. So let's say we got 2 sine 3x. So 2 is just a number that's being multiplied by sine 3x. So now the derivative here, that's going to be k cos f of x times f prime x. So it'll be 2 cos 3x times the derivative of 3x, which is 3, and then you get 6 cos 3x. You could do that easily. Right. Now, what happens when we have, if I, instead of a 2, I put maybe, let's put an x cubed. Now, we cannot go and just write down k cos of 3x here, k cos f of x, because in front is no more just a number. It's now another function of x now. Can you see that? So, what do you do in a situation like this here? You read this as multiplication because it's x to the power 3. There's no plus sign, there's no minus sign, there's no division sign. So therefore it is multiplication. So what you will do is identify the first one here, the first factor there. What do we have here? We have x cubed. Let's write down our x cubed there. And what else do we have? Sine 3x. So what we do here with the product rule, we can call the first factor there f of x and the second one g of x. So now, it doesn't matter which one you call f, which one you call g. Let me start with this one here. Let's call this f and let's call this g. What we're going to do is we're going to differentiate them individually. So if I differentiate x to the power 3, the derivative of x to the power 3 will be 3x squared, and then the derivative of sine 3x, so g prime, the derivative of sine 3x is going to be cos 3x times the derivative of 3x, which is 3. So you can see we are still using the standard table of derivatives. So this is our working out on the side of your page here. You're doing your working out. Now what do we want to find? We want to find the derivative of the whole thing at once. What is the derivative of x cubed multiplied by sine 3x? Here we've done it individually. Can you see that? So now we know that this is f and this here is g. So the product rule works like that. So there is the formula. It's given to you on the formula sheet. So the formula is copy down the first, differentiate, or write down the first term, differentiate the second, plus copy down the original second and differentiate the first. So that's going to be f g prime plus g f prime. It works both ways. If you want to do this part first, you can because it's a plus sign. Right. So now you will copy down this formula. You have all the working out has already been done. Now it's all about substituting correctly. So what is my f? My original f is x to the power 3. G prime here is 3 cos 3x plus g. Original g there is sine 3x. And then f prime is 3x squared. So you're done. There's not much simplification that's required. You can leave it like this here, it's fine. Okay, if you want to multiply, it's not going to make much of a difference. 3 times x cubed. So you'll have 3x cubed cos 3x. But basically, the job is done here. This is just writing down the formula, substituting into the correct place. Okay, so you're going to copy this down, and then you can attempt the first example here. Right, so our first example now, after the worked example, this is the first one that we're going to deal with. So we have 2x to the power 4 multiplied by cos of x to the power 3 plus 1. So what you do is, on the side here, you write down all your information. What is your f, and then your g. Then you can work out your f prime and your g prime. So you can identify f as the first factor there, which is 2x to the power 4, and then g is cos of x cubed plus 1. Now, we differentiate them individually. So the derivative of 2x to the power 4, 2 times 4, that will be 8x to the power 3. And then the derivative of cos. Now, remember, you go to your table of derivatives, you got k cos f of x. So when you differentiate it, it's going to be minus k sine f of x times the derivative of f of x, which is f prime x. So this is y, and this is the derivative of cos. So this is going back to lesson number 1, our table of derivatives. So the derivative of cos is going to be minus sine. So where am I now? It's minus sine of the function of x. Your function of x here is x cubed plus 1. So I'm here at this stage times. So times now f prime x. So what is f of x? F of x is x cubed plus 1. F prime x means differentiate this, so that will be 3x squared plus the derivative of a constant is 0. You can see the main working out is at this stage here. So now, all you do is write down the product rule formula. So this is the product rule. So we're going dy over dx. The product rule is f g prime plus g times f prime. That is your product rule. It's given to you. It's all about placing all the information in its correct place. So f is 2x to the power 4. G prime, we just found g prime here now, which was minus sine of x cubed plus 1 times your 3x squared. So that was your f g prime plus g, which is cos of x cubed plus 1 times f prime, which we just found now is 8x to the power 3. You can simplify this if you want to, but I'm not going to get into simplification. Now the main thing is everything is in its correct place there. Right, so I'm going to leave it unsimplified like this here. Yes. Yes, it depends. Now, if the question states simplify fully, yeah, then you will have to simplify. Right, so now we have division. Okay, so you got division. If you want to, you can simplify 2 over 4, which is 1 over 2. It's up to you if you want to do that in the beginning. And I'm not going to deal with that. I'm not going to simplify in the beginning now. So if you have division, right, so you got a variable on the top, variable in the bottom. So you know, if it's division and you're asked to differentiate, then we are going to be using the quotient rule. Right, so now, the quotient rule, you identify your numerator as f, so that will be your numerator, and then identify the denominator as g. So let's write it down. So my f of x is 2 log of tan x to the base 4. So what am I dealing with here? I'm dealing with k log f of x to the base a. That's from our table of derivatives. Right, and then my g is the denominator, which is 4 e to the power sine 2x. So what am I dealing with here from the table of derivatives? It's k e to the power f of x. Right, so this is what you must have in your head, okay, when you see any one of these problems. So now, f prime. So what is the derivative of k log f of x to the base a? The derivative here is going to be k times f prime x all divided by f of x ln a. That is a formula to differentiate log. So we got 2 multiplied by f prime x. So what is my f of x? F of x here is tan x. You can see that? So f prime x means differentiate tan x. The derivative of tan x will be sec squared x. So sec squared, let's be more specific, 1x times the derivative of 1x is 1. You don't have to write that down, but that's what's actually happening. Right, so that is k f prime x all divided by f of x, which is tan x times some here, natural log of the base, so that's going to be ln 4. So that's sorted out now, you know. Right, so now the next one. Differentiating 4e to the power sine x. So g prime, so let's write down what is the derivative here. Go to your table of derivatives. The derivative of ke to the power f of x is ke to the power f of x times f prime x. Okay, so that's going to be 4e to the power sine 2x. That means ke to the power f of x. F of x is sine 2x times f prime x. F prime x means differentiate whatever you have and write down the answer here. So differentiate sine 2x. That means you're going back to the table of derivatives now. Can you see that? That's why it must be in your mind. Right, so you just switch in a few seconds. You know everything is in your mind. The derivative of sine 2x is going to be cos 2x times the derivative of 2x, which is 2. So 4 times 2 will be 8e to the power sine 2x times cos 2x. This is the main thing here. Right. Once this is sorted out, the rest is easy. Now go copy down the formula. So we're dealing with the quotient rule. So the quotient rule, dy over dx. The quotient rule is copy the denominator, differentiate the numerator. Minus copy the numerator, differentiate the denominator, all divided by the denominator squared. That is the quotient rule, which is given to you, so you're not going to make a mistake. And now it's all about substituting in its correct position, its correct place. So what is my g? G is the original denominator there, which is 4e to the power sine 2x. F prime is what we just found there. So that is 2 sec squared divided by tan x times length 4 minus f, which is 2 log of tan x to the base 4, and then my g prime, let me just use it, there's my g prime here. My g prime is 8 e to the power sine 2x times cos 2x, so that's my g prime, all divided by the denominator squared. So what is my denominator? It is 4e to the power sine 2x, and the whole thing is squared, and that is the main thing you need to know. Let's not worry about the simplification at the moment. That's the main thing. The main thing is know your table of derivatives, substitute correctly. Alright, so now dealing with the last one here, number 3. Again, division. So if it's division, then quotient rule. But now, if you look at the numerator there, our numerator, remember, is f, denominator will be g. So our numerator is 5 tan of 5x squared, but the whole thing is raised to the power 5. Okay, now if you have something which has an exponent which is not positive 1, okay, then use your brackets, and remember, look at the position of this exponent here. It means everything here is raised to the power 5. So introduce your brackets, write it down properly, and we know now what's inside here is just tan of 5x squared. The whole thing is raised to the power 5. Okay, so when you differentiate this here, so when you find f prime, what rule are we going to use? When we have an exponent which is not positive 1, any other number, then what rule do we use? Remember, we did it yesterday. Here we have k f of x to the power n. So if y is equal to k f of x to the power n, then to differentiate this, we deal with the exponent first, which is going to be k times n f of x to the power n minus 1 times f prime x. So what rule is this called? This is called the chain rule. When you have a power, because now if you go to your table of derivatives, and if you look for k tan f of x, the derivative of k tan f of x, so if I got y is equal to k tan f of x, the derivative of tan is going to be sec squared f of x times f prime x. That is it. But when do we use this? When do we use the table of derivatives just at once? Notice the power is not shown. What is the power? It's always positive 1. But when your power is not a positive 1 now, it's any other number, then you don't go straight and write down the answer there. You have to first deal with the exponent first. So that's going to be k multiplied by n. So let's do it here. So this is going to be 5 times 5 there. Then I got tan of 5x squared. And now I got 5 minus 1. So what am I doing here? Dealing with the exponent first times. Now the focus is on what's inside. So whatever is inside the bracket, you differentiate it and write down your answer outside. Okay, so what is inside here? It's tan. So now I can go to my table of derivatives. What is the derivative of tan 5x squared? It's going to be sec squared of 5x squared times the derivative of 5x squared, which is 10x. Okay, remember sec squared f of x times f prime. So here we got 5 times 5, which is 25, and that is tan of 5x squared. 5 minus 1 there is 4. Then we got 10x times sec squared of 5x squared. If you want to, you can multiply, since it's all easy to multiply here. 225 times 10 is going to be 250x times tan of 5x squared to the power 4 times sec squared of 5x squared. So that is a derivative. Why did we do this? Because we had a power of 5, we had to apply the chain rule. Right, so that was that sorted out. What is g now? The g is the denominator there, which is 3 ln of sec, just sec x. So now, what is the formula for differentiating ln sec? Go to your table of derivatives. If you got ln of f of x, the derivative here is going to be f prime x divided by f of x. That is the formula for differentiating ln of sec. You should have this in your head. Right. So now, g prime, if I differentiate here, so it's going to be, well, 3 is just a number multiplied by f prime x. What is f of x? It's sec. So f prime x means differentiate this here, which is going to be sec x times tan x, all divided by f of x, which is sec x. So your answer is just 3 tan x, because sec and sec will cancel. Can you see that? So you got your f prime, g prime. Now the main job has been done. Now you can see that. Now all we have to do is write down the formula, the quotient rule. So we're going dy over dx is going to equal to g f prime minus f g prime, all divided by g squared. I'm just going to substitute now. What is my g? G is the denominator, which is 3 ln sec x. F prime, what was my f prime? It's this here. So that's 250x tan to the power 4 of 5x squared times sec squared of 5x squared. So that's gf prime minus f, which is 5 tan to the power 5 of 5x squared. G prime, which we just found now, which is 3 tan x, and everything here is divided by the denominator squared, which is 3 ln sec x all squared. This is just the substitution. So that's g f prime minus f g prime all divided by g squared. Alright, we continue next time.